We're going to talk about ISBN numbers and some other things like UPC, which are examples of where check digits are used. So first, I have a PowerPoint that I'm going to go through kind of quickly. I don't have it posted on Moodle. I'm not expecting you to get anything from this. I just want to show you kind of where check digits are used and a bunch of examples. So this is actually not my PowerPoint. This is a PowerPoint from Joe Gallion, who's like the most famous math professor in our department. He's actually the president of the American Mathematical Association of America. Like, he's a really highly regarded mathematician, and he's a really interesting guy. So one of the things that he's obsessed with is the Beatles, and so he actually used to teach a class on the Beatles too, and I was his TA for it, so that was kind of fun. And he's a funny guy. So he has things like a Yellow Submarine cookie jar, which costs $69.99. So I'm telling you that because probably not a lot of people would buy a Yellow Submarine cookie jar for $69.99, or maybe he got it for a gift. But one of the things Joe likes to do is he likes to look at things. He's a mathematician, and he notices where a lot of these things come from. So if you see the 3 here that's circled, that's called a check digit. And what the deal is we have a UPC here, a UPC code, which has all these lines, and then a scanner is used to scan it, right? Each of those like a couple of those lines together are actually identifying a particular number, and then the numbers are shown underneath. And so these numbers, what do you think they're standing for? Like, what you scan this, and what does that do? Like, why is there UPC on stuff that you buy? Like, it's identifying the product and the information about it, right? Probably most importantly the cost, so that you don't have to type in, this is $69.99 or so on and so forth. So what the check digit's doing is it's not having any new information about the product or anything. It's just checking to make sure that all these other numbers are correct. And so if there was like a part of the barcode that was missing, or if somebody had actually entered the UPC numbers and they made a mistake, then what that last digit does, or the check digit, is it would kind of help detect if there was an error. Because maybe some really expensive item would come up and you'd just be charged $169.99 for, I don't know, the whole Sgt. Pepper's Lonely Hearts Club Band costumes kit or something. I don't know, something that's way more expensive. So it's a way to kind of make sure things are checked and you don't have lots of errors. So here's another example, and this is one that we're actually going to work out and look at. If you look at your formula sheet, there's, on the bottom of the first page, you can see there's a thing about ISBN and UPC. Those are the 2 examples where we're actually going to manipulate a little bit and actually do some of the numbers. And I have some formulation for that. So we're going to go over examples today of types of questions that ask with ISBN and UPC. Reminder that on your assignment you have the odd solutions worked out for you as well, and those solutions are posted on Moodle right now, so that's an extra resource so that you can finish the clock, math, and check digit assignment that's due Monday, okay? So that's what we're going to actually do with the math stuff, with formulas. You're given the formulas, but again, the purpose of this PowerPoint showing this to you is just to kind of show you like a whole bunch of examples of where check digits are used. So one place is on checks. So checks, we have a routing number, and the last digit here of the identifier for the bank, I believe is what this first part is a check digit. It also cuts down on fraud. So it's not just an error detection kind of thing, it's also a fraud thing, because then when we have a check, unless you know exactly how the check digit is formulated, if it's not right, then that would be a way of detecting that it's fraudulent, right? So there's kind of an extra piece here that there's a layer of security that people use check digits for, because what happens here is you use the digits in the meaningful part that's saying like what the bank is. You do some calculation with that, which is explained again for ISBN and UPC on your note sheet, and then you should get the check digit. And if you don't, then it's like, well, this is a counterfeit or something like that. So that's another reason we have check digits on lots of things. So here's an airline ticket. There's a check digit at the end of that. And then I should mention the algorithm for these, or the actual formula that's used, is different depending on what it is. We know what ISBN and UPC are, and we're going to do those, but there's some companies that have like a check digit and it's not public how it's calculated, because it's a security thing. So traveler's checks, kind of a security thing. Car rentals, that's sort of like a barcode type thing, has a check digit. Some money, like the euro, for example, has an identifying number in one of those digits. The last one is a check digit. So again, for kind of cutting down on fraud and that kind of thing. VIN number on a vehicle. So it's identification number on a vehicle. So if you gave somebody gave like a made up one and they just looked at it and they didn't know the algorithm for the check digit and they got it wrong, then you would know that something's up. That that's not a real car or something, or that's not the actual VIN number. UPS, a receipt here for a money order. So this is the kind of, these are all from Joe, by the way, again. So this is the kind of thing he does. He's like, oh, where's a check digit in this one? And he's a really good mathematician, so he actually figures out what the algorithm is and stuff. So even postcards we get in the mail, there's a mailing code here. Uses a check digit. Credit cards have a check digit as one of the digits in the code. Not sure what that was. It's showing that the check digit wasn't right. So that's another thing when you have you give a credit card or scan it or something like that. If it doesn't go through, that's one of the things they're authenticating when you buy something online, and it's like, okay, wait a minute, we're making sure your number's actually for real. And they don't know for sure, but I mean, with this check digit, is a way to be like, it's probably legit. Okay, here's an ISBN. What are ISBN used for? So the UPCs are like for products that you buy at the grocery store, like Kellogg's Cornflakes is one that we're going to deal with. But what are ISBN used for? You should know this because you're a college student. Textbooks, or books in general. Okay, just tons of these everywhere, behind the scenes. Some of these are kind of out of date, like buying CDs in a mail order thing. Do you guys even know about that? It's like something from my childhood. There was like CD clubs, get CDs sent to your house every month. You'd have to send them back, or you'd be charged for them if you didn't like them. That's what that was about. Diapers. Okay, and so then Joe gives this presentation to math majors, so then he, throughout this, the rest of this presentation is kind of getting into some of the nitty-gritty. Your guys' ID looks different, but actually in your library, your barcode, all this stuff has a check digit in it. All the codes you have with UMD. Driver's license is kind of the interesting thing, because each state has its own way of calculating a check digit, and it's not public again, because if it was public, then people could counterfeit a driver's license, and that would be really bad, right? Because we use driver's license for identity and making sure people are who they say they are and stuff like that. And Joe had a contest for trying to figure out a Wisconsin driver's license check digit. I think I can't remember if he figured it out and he just had a reward for it, or he actually didn't know and he wanted someone to figure it out. Here was some samples, and so some people, Scott McRae figured it out, and then he wrote him a check, I guess. So if you have a large enough sample, then you can try to figure these things out, like what is the algorithm to get that check digit. So I think this is getting to kind of the math major stuff. We're not going to go in quite this much depth. Just making sure there isn't anything else here. Okay, I think that's good. All So any questions so far? Don't have to get anything like I'm going to ask you on the test or something from that. I just wanted to show you Joe had that wealth of all those examples that he scanned in and wanted to show those to you. So we're just going to focus on the ISBN and UPC. So we'll start with ISBN, look at that on your formula sheet. This is what you're going to have in the test. We're not going to actually use the information about like the group number and the publisher and stuff. That's just trying to get to like what the meaning is of those, and that those are meaningful things that are telling you about the book. And so if you have those digits, then you know like what the book is and what edition and all that stuff. So the last digit in the ISBN is the check digit, and that's not containing information about the book. It's just using some calculation with the other digits that are information about the book in order to say, hey, are those right, or is there a mistake? So ISBN stands for International Standard Book Number. There's 10-digit and 13-digit variations. We're just going to go over the 10-digit. So the first 9 digits are, again, information about the book. And the 10th digit is the check digit. And so this checks for mistakes with the meaningful digits. So we have some notation here on your formula sheet. It says A with a little 1, A with a little 2, so on and so forth. And so what those are denoting is the first number, the second number, A2 is the second number, and those little numbers are what are called subscripts. You might remember, we're not going to do this in this class, but the slope equation of a line, straight line, is y2 minus y1 over x2 minus x1. You guys remember that formula? So the A1, A2 is kind of a similar notation where it's denoting like A's are the digits in different places, and the 1, 2, 3, etc. are telling which one it is. So y2 and y1 would be like a y coordinate for one point and a y coordinate for another point. So it's a notation that shows that they're different and like gets some information about it. So that's what those are. You just need to match up the digits in your exact problem. So in this example that we're going to do, we're given this ISBN right here, 81752576660. So it's 10 digits, and it says verified 0 is the check digit. So you might want to get out your assignment, ask a little bit different questions here and there. I need to get mine out. Anybody need it? Got a Q extra, you can come up. So where we are on this assignment is on the second page, starting with ISBN numbers. It tells you which ones are due for the assignment. The solutions to the other ones are on Moodle. So the formula you have on the formula sheet for ISBN has a little formula for A sub 10, which is the check digit. So on the assignment, on number 14, for example, it tells you the first 9 digits, and then you find the last digit just by using that formula for A sub 10. So that's one type of question that I would ask you to do. If you take a look at number 17, that question is stated a little bit different. It says if 013143243-3 is a valid ISBN. So determine if it is or not. So do you guys have any ideas on how you would determine that if you have a formula for A sub 10, the last digit, the check digit? You could do it very similar to the problems before this, 14 through 16. Good. Do the exact same thing with the first 9 digits, and then see if it matches the last digit, which is the A sub 10. Perfect. Does that make sense? So those are the two types of questions I could ask you to do. The work involved is pretty much the same. It's just the conclusion, you tweak it to the problem. So for this one, I'm sort of asking that second type of question, verify 0 is a check digit. Like, let's make sure that 0 is a valid check digit. So the formula you have in your formula sheet is A sub 10 is equal to, and then it's kind of a complicated formula, we got parentheses, and we have A1 plus 2A2 plus 3A3. So notice the pattern continues, and then for the first 9 digits, or the ones that have meaningful information, you're just multiplying the position, like if it's the first position, second position, times the digit in that location. You know, you don't have to memorize that, but that's what the formula is saying. And then, ooh, look, mod 11. Modular arithmetic is coming up again. So we'll be doing the mod 11 thing in a sec. Okay, so let's write this out for our example. So we have 8 for our first digit, or a sub 1, and then a sub 2 is 1, so we're going to take 2 times 1. And then we have 3 times the third digit, which is 7. And then we have 4 times the fourth digit, which is 5. Then we have 5 times the fifth digit, which is 2. Then we have 6 times the sixth digit, which is 5. 7 times the seventh digit, which happens to also be 7. So on and so forth. 8 times 6. 9 times 6. Now on this one, make sure you stop short of doing the last digit, because that's actually what we're trying to calculate, right? So don't include that one. Order of operations, we do all that multiplication first, and then we're going to add. So 8 plus 2 plus 21 plus 20 plus 10 plus 30 plus 49 plus 48 plus 54. Find that answer, 242 mod 11. Now you guys know how to do the rest of this. How do we find 242 mod 11? Divided by 11. So if the number 242, in this case, the number that comes first is greater than or equal to the mod 11, the 11 part that comes second, then what this is saying, first of all, is where in 242, or where in the cycle of 11 is 242. So it's going to go through a bunch of cycles of 11, and then in the last cycle of 11, where does it stop when you get to 242? So the way we can find that is we do long division, where 11 is the divisor. So 11 goes into 24 twice, we get 22, and 11 goes into 22 exactly twice, and we get remainder 0. So the answer to this is 0. And now what is the question? Well, I didn't actually ask a question overall, which was not good of me. But verify 0 is a check digit. Did we verify it? Is it correct? Okay, so let's conclude by saying, hey, we got 0, which is the same, it's verified. We got the same number. So do we have any questions about the calculation? How to do it? So you have this example, you have also the odds solutions on Moodle. So just a little bit about kind of talking about how this works a little bit. This particular ISBN check digit, the way it's calculated, is kind of complicated, right? We're using every single digit, and then we're multiplying each digit by a different number. So it turns out that it's 100% accurate, that check digit, if it's wrong. We would be able to detect 100% of the time that a single digit was switched. So if we had, like, instead of 817, it was 187, and then the rest of the digits were correct, because that's a common error. People switch digits, right, if they're entering it. The check digit would catch that that's an error 100% of the time. So it's really good at catching that kind of error. It's also 100% accurate at single digit error, so if I misread the 8 for a 9 or something like that, and I put 9175, whatever, it would check that with the check digit. So if I put in a check digit of 0, and I entered a 9 as the first digit, be like, sorry, that's not right. try again. 100% of the time it would catch that error. Now other errors, if you mess up 3 digits, then the accuracy goes down. It's not as accurate at catching those errors. It still has some detection power. We're not going to go into the reasons why. But compared to the UPC, look at the formula for UPC on your formula sheet. That one's going to be a little bit less intensive to calculate, and that one's going to be a little bit less good at catching errors. So on some level we can kind of say like, oh, we had to use every single digit and we were multiplying by a different number every time, and doing that calculation was going to make our check digit a little bit stronger at checking errors, or catching those errors. So going on to UPC. I'm just using that image from Joe's presentation with the Kellogg's Corn Flakes. So not all the digits are written out as we're accustomed to, like the 38000. Can you guys see with the 000 what the symbol is in the barcode? It's kind of that thick line followed by a thin line. See, when you have the repeats, you can see what it is. But then the spacing, you know, it's kind of hard to tell from there. But sometimes the check digit, like in this, is actually not displayed. So the barcode for 7 is this last part, and that's actually the check digit. It's not even written down, but if you scan it, it would detect it. So UPC is formulated a little bit differently for a couple of reasons. So if you take a look at it, it's formulated differently than the ISBEN. ISBEN, we were calculating the 10th digit, and we had a formula for that. This one says you have a valid UPC when you do this calculation mod 10 and you get 0 for an answer. So let's look at the assignment. Last page, backside, for UPC. So notice that 21 through 23, the standard problems say determine whether the following UPC number is valid or not. You're given the whole thing, and you're going to do the calculation like that's on the formula sheet, and that's how you're going to be able to tell. If you get 0 for an answer, it's valid. If you don't get 0, it's not valid. Alright, so before we move too far, I realized that I forgot to, I'll just mention this quickly. We took this mod 11, and we have 10 digits, 0 through 9, in our numbers. So when you take it mod 11, on your formula sheet, it says if you get a 10 for an answer, which is a possibility when you take some mod 11, what does the formula sheet say that you let it equal? An X. Because 10 is 2 digits, right? So to have the digit and the check digit, they make it an X. So it's one symbol for one place. So it tells you right that on the formula sheet, but I forgot to mention it. So, and then also if you take have a larger modulus like mod 11, that makes the detection of the errors stronger. If you take it mod something less than 11, like mod 5, then you'd start having repeats of possibilities that you would get for an answer, and then you wouldn't detect as much. So, anywho. Okay, let's go, back to UPC. So we're just going to use the one on the Kellogg's Corn Flakes, which actually has some hidden digits in there, so there's an extra 7 that you can't see, but I'm not going to give you the UPC and have you know what those lines mean or be able to translate that. So you just be giving it in number form. So the UPC for that Kellogg's Corn Flakes is 03800001277. That's the whole deal. And now you use every single digit, and then you do this calculation and see if you get 0. So now we're using all the digits, not just the first ones, and leaving out the last. So what does this say? It says 3 times the sum of odd positions plus overall the sum of the evens positions, and then you take that all mod 10. So here's where kind of the reason why we have that weird notation. with the a sub 1, a sub 3, a sub 5, etc., is so that we could do this. That little subscript, the little number there, a1, a3, a5, those are odd position. 1 technically is not odd, but let's, if you had to identify odd or even, you would say it's odd, right? Because 2 is even, so pretend that 1 is actually odd for real. And so just take the odd position. It's not the odd numbers. So look, for example, 8 is in the 3rd position in this example, right? Right here. Is 8 odd or even? 8 is an even number, right? But it's in the odd position because it's an a sub 3. So when we look at this formula, notice that it says the position, the odd position. Does that make sense? Because that's the most common mistake people make. So going through the positions, let's do this. We're going to have 3 parentheses, sum of the odd positions, so that's going to be the first one 0, the 3rd one 8, the 5th one which is a 0, the 7th one which is a 0, the 9th one which is a 1, and the 7th one, or not the 7th one, the a sub 11, and then plus the sum of the even position. I don't actually need parentheses here, but I'll put it in there. And so we have the 2nd position 3, the 4th, so on, and so forth. Notice that we are using the last digit, a sub 12, in this calculation. We didn't for ISBN because it was a different formulation. And then we're going to take that mod 10, and we're checking to see if that equals 0. So I'm going to put a question mark there, because otherwise you'd be like, well, why are we even doing this? Because it's equals 0. So order of operations, we need to do the addition that's in the parentheses first. So if you do that, you get 16. And then I guess technically we have those parentheses the way this is formulated, so I can do that and get 12. Then what? Multiply or add? Order of ops, we do multiplication, so we get 48. Then add 12. You get 60. And some of you are so good at this, I bet you can do it in your head. I'll show the work, but what's the answer to that? It's a remainder, right? 0. So is it valid or not? It is valid, but let's show our work. So 60 goes in the box, 10 is the divisor, and so it goes in 6 times, which is what some of you are saying, but remember the answer is a remainder. So that's 0, so yes, which means it's valid. Questions? That's it. So let me stop the recording here quick.